Let's look at a subtopic, a continuation of electrolysis, half-cell equations, writing and balancing. Half-cell equation is used to represent the reaction that happens at the electrodes, that is the anode and the cathode, during electrolysis. It shows what happens when ions gain or lose what? Electrons, right? So let's look at what a half-cell equation entails. In half-cell equation, one electrons are shown as this. The number of atoms of each element must be the same on both sides. The total charge on each side must be the same. Usually 0. Sometimes it can be what? Negative coefficient at both sides of the equation. Let's look at how you can write cathode half-cell equation for the following cations. Welcome back. Anode half-cell equations, writing and balancing. This is chemistry 0620. Negatively charged ions lose electrons at the anode. These are half-cell equation for reactions at the anode. Let's look at this closely. I'm going to start with chloride ion. Chloride ion. If you look at chloride ion, we go to the anode. Because the anode is positively charged electrode. This is negatively charged ions. Unlike charges attract, and this definitely will be formed at the anode. Now, chloride ion to the anode, and it forms chlorine gas. But how is this one actually actualized? Looking at, we use how electrons are transferred, right? Look at the atoms here. Chlorine atom here is an element. Here is 2, right? It's 2, and here is 1. So we balance that by putting if here is 2, we put the 2 here. So this here is 2 atoms of chlorine, and this is 2 atoms. There is a subscript here. Here is a coefficient. Atoms are balanced. Now, in terms of their charges, we are told that the total charge on each side must be the same. Right? This side is 0, because there is no charge, electrically neutral. The net charge here is 0, but the net charge here is negative 2. So how do we balance this? So if here is -2 and here is 0, so we now introduce 2 electrons, right? 2 times -1 is -2. So here electron will be given. So the total charge here will be -2, and here is -2. So this is the half-cell equation for the discharge of chloride ion forming chlorine gas at the anode. Anode. Let's look at others. Now, if you look at oxide ion, right? From the electrolyte, one of the anions there, oxide ion, which is an anion, we go to the anode, and you find bubbles, right? This is a gas bubble at the anode. Now, if you look at it again, in terms of the number of atoms of each element on both sides, here is 2 and here is 1. So how do you balance them up? You put 2 here. So atoms, oxygen here is 2, oxygen here is 2. Subscript coefficient. So this oxygen, the number of atoms of each element, oxygen are both balanced, right? Now, how about the charges? The charge here is 2 times -2. You have 2 times -2, you have 4, and here is 0. So to balance this other side, we introduce 4 electrons. 4 times -1 is -4. So 0 plus -4 is -4, right? So the total charges here is -4, the total charge here is what? -4. So this is what? Balance. The electrons are written on the right hand side, right? Don't forget the right hand side. Now let's look at another one which is more interesting, the hydroxide ion. This is hydroxide ion, right? Hydroxide ion, probably from what? Water. So if this one gets to the water anode, what are the products? Definitely O is here, oxygen, that's form the hydrogen. You balance it up, the hydrogen, then you add what? Water, right? The hydrogen, you write what? Water, right? And for the oxygen, you write this. Now let's look at the number of what? Atoms, right? You have here the atoms here are not what? Here oxygen here is 2 plus 1, that's 3, oxygen here is 1, hydrogen here is 1, and here is 2, so they are not equal. So how do we balance this? To do this, we can introduce what? 4 here. Oxygen here is 4, hydrogen here is 4, and we put what? 2 here, right? Hydrogen here is 4, hydrogen here is 4, oxygen here is 2, here is 2. So if you look at the atoms, oxygen, hydrogen, right? The oxygen here is now 4, the oxygen here is now 4. 2 plus this 2 is 4, and hydrogen, the coefficient here is 4, and here 2 times 2, that's what? 4. So the number of atoms on both sides are balanced, right? The number of atoms of elements, right, at both sides balanced, right? So let's look at what? The charges, right? The total charge on each side must be the same. The total charge here is -4, and here is what? 0. There is no charge here. The net charge here is 0, the net charge here is 0. So to balance, to make this side to be -4, I need to what? I need to add 4 moles of what? Electrons. 4 moles of what? Electrons. That will be 4. That's what? That's it, right? So you have -4. This is the left hand side. Then the right hand side is 0 for this, 0 for this, and this is -4. So -4 equals -4. So this is the what? Anode half-cell equation for the discharge of hydroxide ion. At the what? Anode, you would form oxygen or gas, water. So this one is observed, right? And you have 4 electrons given to the what? Anode. Given to what? The anode. Here you have what? Also 4 electrons. For chloride ion, produces what? 2 electrons given up to the water anode. And electron loss, if you look at the acronym OIL, it's an acronym OIL. This is oxidation, is what? Loss of what? Electrons. Of what? Electrons, right? So electron loss is what? Oxidation. Electron loss is oxidation. All of these, right, are all carrying out oxidation. That means the chloride ion is being what? Oxidized to chlorine what? Gas. And oxide ion oxidized to oxygen gas at the anode. Hydroxide ion oxidized to oxygen gas and what? Water. Don't forget. Now, and these electrons, where did they move to? We know that if you have this as your anode, right, and this is the electrolyte here, electrolyte, right? Now this is the anode, and you connect this to an electrode, right? Is the anode, you connect to the what? Positive terminal of the battery, right? This is the battery or the cell, right? And this is a negative connected to the other part of it, and this is the cathode, right? Like a chloride ion, you see we lose electron, and these two electrons aggregate, and these two will now become this now discharge as what? Chlorine gas. The electron will now move up, pulled by the battery, and it comes here. So this is plus 2e. Now let's assume you also have calcium ion. Calcium ion will take the two electrons and become what? Reduced to calcium, right, at the what? Cathode. So electron is always lost, negative. Electron is lost. Electron lost at the anode is electron gain, plus at the what? Cathode. Electron lost by anions at the what? Anode, and the anion become a gas, oxidized to a gas. The same electron being pulled or pushed by the battery to be gained by cations and to become what? Neutral atoms, right? Neutral what? Atoms. So it's a redox reaction. What takes place here is oxidation. What takes place here is what? Reduction, right? Both occur simultaneously. So oxidation plus reduction equal to redox. So it's a redox reaction because oxidation and reduction are taking place simultaneously, right? Electron lost here is electron gain, right? So that will lead us to the next subtopic, how to write the net of full ionic equation, showing what happened at the, to present what happened at the anode, they don't present what happened at the cathode. So you now sum them together. If the electron transfer here and here are equal and what? Opposite, they cancel out. So you now write the the net ionic what? Equation, or the full ionic equation. So don't forget, I'm still trying to explain one thing, how to write and balance anode half cell equation for some anions. I have chloride ion, I have oxide ion, and hydroxide what? Ion. So don't forget this, find time to study this and do more, right? You can try your hands on how to form the half cell equation for other anions. Other anions will be given to you in the next proceeding work. I hope this is understood. Find time to write me. This is my WhatsApp number as plus what? 220308322. That's my WhatsApp, right? Take care and stay blessed.